Hey guys, we're on Unit 10 and we're going to do day 4 today, and we're going to do polynomial long division. Okay, so we're going to go all the way back to when you actually learned division. And in this box here gives us a little bit about what you may or may not remember about long division. All right, so when we have, let's say our example is 16 divided by 3, and we want to know how many times 3 will go into 16. We set it up as 16, which is called the dividend, underneath the divide sign. Okay. Also be careful with the divide sign. It's just straight up, straight across. Some people will make it a little bit curved here and then straight across. But remember that a check mark like this is not a division sign. That is a radical or a square root, which is a different sign than what we're using today. So be careful, okay? Make sure that your division sign does not look like a square root, all right? We are not square rooting 16. We are dividing into 16, and we are dividing the number 3 into 16, and 3 is called the divisor, okay? When we do long division, we ask ourselves, how many times does 3 go into 16? And it goes in 5 whole times. And that 5 up there is called the quotient. Okay. What you do next is you multiply 5 times 3 to get 15, and it goes under the 16, and you go ahead and use subtraction, and you end up with a 1. Well, that leftover of 1 is called the remainder. All right. So hopefully that's bringing things back. In Algebra 2, when we are asked to long divide, we are going to be long dividing polynomials, but we're going to review with numbers in number 1 and 2 just to bring back some memories, all right? When we're finished, they could ask us to put our answer in what they call quotient remainder form, where your quotient, which is what is on the top of the divide sign, okay, your answer, okay, plus your remainder divided by your divisor, all right? So in this case, if we were to write our answer in quotient remainder form, our quotient is 5 plus the remainder of 1 at the bottom divided by your divisor, which is 3. So it'd be 5 plus 1/3. Okay? 5 plus 1/3 is really 5 and 1/3, which is 16/3. Okay? All right, let's go ahead and take a look. So in number 1, they're asking us to use some long division. Okay? And so we're going to go ahead and set this up. All right. So when we set up our division sign, 7 is what is going in. So it goes on the outside, and it's going into 1,519. Okay. All right. And here we go. So we're going to ask ourselves, 7 times what is 1? Nothing. So 7 times what is 15? And we're going to say 2. 7 times 2 is 14. We use subtraction, and we end up with 1. Then we bring this other 1 down, and we say 7 goes into 11 one time. 1 times 7 is 7. We use subtraction, and we end up with 4, and then we bring the 9 down. 7 goes into 49 7 times. 7 times 7 is 49. Use subtraction, and we get a 0. All right. So it says, what is the remainder? And the answer is 0. Okay, we had no remainder. Okay. Write an equivalent equation using multiplication. So we're going to take 7 times 217, and that would equal 1,519. Okay. Could you call these parts factors of 1,519? And the answer is yes. Factors have multiplication in between them. So yes, because they are multiplied together. All right, so we're going to go over to number 2. It's extremely similar. You're going to just see that the numbers changed a little bit on the top, but we still want to know how many times 7 will go into 1,522 this times. All right, so again, 7 times what is 1? Nothing. 7 times what is 15? The answer is 2 is the closest. All right, and so we subtract, we get 1, we bring down our 2, 7 goes into 12 once, 1 times 7 is 7, so we have leftover of 5, we bring down the 2, 7 goes into 52 at most 7 times, 7 times 7 is 49, and when we subtract, we end up with a 3. There's nothing else left to pull down, and so therefore our remainder is 3. Okay. Write an equivalent equation using multiplication. Well, we can't just alone use multiplication in this one. We can do 7 times 217, but that's only going to give us 1,519. So we're going to have to add on our remainder of 3, and then our equation would be 1,000 equal to 1,522. So could you call these parts factors? And the answer is no, because it's not just multiplication. There's that addition in there too. Okay, because not just multiplication this time. There is addition too. All right, so here we go. We're going to go ahead and do some long division with polynomials. So in number 3, okay, they're asking us to see how many times x plus 6 will go into 2x squared plus 15x plus 18. And so here we go. X plus 6 is going to go on the outside. Our division symbol in our polynomial that x plus 6 is going into goes underneath. All right, so what we should be concerned about is just the x going into the 2x squared, even though the 6x will follow, okay? So we're going to say x times what is 2x squared, and the answer is 2x. All right, and now we're going to go ahead and multiply. So 2x times x is 2x squared, and then 2x times the 6 is plus 12x. All right, we're going to go ahead and use our subtraction sign. However, we got to be careful that when we subtract all the terms after it. All right, so I like to treat this like a button on my calculator, so that's why I put a box around it. And so I'm going to hit it every single time that I go down with a like pair of terms. All right. So when I do 2x squared minus 2x squared, those cancel, which is exactly what's supposed to happen, okay? But now you have 15x minus 12x, which is 3x, okay? If you forgot to hit the minus button over there, you might have said 27x, which will change your answer, all right? So make sure that you're subtracting. All right, so go ahead and bring down this positive 18. And we're going to ask ourselves how many times does x go into 3x? And the answer is 3 times. So we're going to write a positive 3 up here. And now we'll multiply. So 3 that we wrote up here times the x is 3x. And 3 times the 6 is positive 18. We're going to put our subtraction sign out here, treat it like a button on our calculator, and every time we go down, we hit it. So 3x minus 3x, cancel. 18 minus 18 also cancel, and there's nothing left to bring down, and so you guys can see that our answer is 2x plus 3. Okay. Is there a remainder? No. Write an equivalent equation using multiplication. So that would be my x plus 6 times my answer of 2x plus 3 should equal my polynomial of 2x squared plus 15x plus 18. Okay. And could you call these parts factors? And the answer is yes, because they're being multiplied together. All right. So yes, because being multiplied together. And what that means to me, guys, is that you could have factored 2x squared plus 15x plus 18. Okay. All right. Coming over here, guys, to number 4. A similar question, but you guys can see it's a little bit different. All right. So we're going to go ahead and set it up with the x plus 6 on the outside. The 2x squared plus 15x plus 20 on the inside. And we're going to go ahead and see how many times x plus 6 goes into it. So remember, we're just focusing on x going into 2x squared, which is 2x times. So that 2x times x is 2x squared, and 2x times 6 is 12x. We're going to put our minus sign out in front here, and we're going to subtract every time we go down. So 2x squared minus 2x squared cancel. 15x minus 12x is 3x. We're going to bring down our positive 20. And now we're going to ask ourselves how many times does x go into 3x? And the answer is 3 times. And 3 times x is 3x. And 3 times 6 is 18. Put our minus sign out here. And every time we go down, we press it. So 3x minus 3x, cancel. 20 minus 18 is 2. And so now it says, is there a remainder? And the answer is yes. Okay, it's 2. And it says write an equivalent equation using multiplication. So that would be an x plus 6 times a 2x plus 3 plus 2 equals 2x squared plus 15x plus 20. Okay. Could these parts be called factors? And the answer is no. Okay, because there is also addition. Okay. Factors can only have multiplication. All right. So hopefully that helps with a little bit of long division, and we're going to go ahead and try some examples on the backside. I'll see you guys there.